percent composition. There is a formula that we use called percent composition by mass, in which the mass of the part is divided by the mass of the whole times 100. This is also the same formula that can be found on table T of the chemistry reagent reference table. This is the very last page of the reagent. Note that the formula that you want to look at is this particular formula. Let's take a look at an example. In example 1, we want to find the percent by mass of oxygen in CO. So to calculate this, we're going to use this formula, which we have mentioned before. Composition of mass of parts divided by mass of whole times 100. However, we need to know what the formula mass or the mass of the whole is for CO. So we got to calculate that, and we're going to use the formula mass for that. So C, there's 1 of C, and there's 1 of O. And so atomic mass of C is 12, and atomic mass of O is 16. So we calculate that to be 12 and 16, which gives us 28. So this right here is the mass of whole. So now we want to figure out the percent composition. So the percent composition then is percent is equal to the mass of part. So the mass of part of oxygen is 16. So we're going to do 16. And the mass of whole is 28. We're going to multiply that and then divide that and then multiply by 100. So that will give us 57.14%. In example 2, we want to find the percent by mass of oxygen in Fe2O3. So again, we are looking at the percent composition by mass, which is mass of parts over mass of whole times 100. So let's figure out the formula mass of the Fe2O3. So we have 2 Fe and 3 O. So the atomic mass of iron is 56, and atomic mass of oxygen is 16. So that makes it 112 for iron and 48 for oxygen. That gives us 160. So now let's figure out the percent composition. So we know that oxygen is 48. Remember, we are getting the entire mass of oxygen. And we know that the mass of the whole is 160 times 100. So that will give us 30%.